we go further. Let's recite Surah Al-Fatihah. إياك نعبد وإياك نستعين صراط المغضوب عليهم آمين. And now we go to the third part of chapter 1, part of complex number. Then complex number always written as this. This is the general form of complex number, and we represent by Z. Z equal to A plus BI. We write our complex number in terms of A plus BI. And remember that our complex number consists of two parts. This is real parts and imaginary parts. Real and imaginary. Real parts of complex number is A, and the imaginary parts are B. Two complex numbers are equal if their real parts are equal and their imaginary parts are equal. If they equal, we can say that these two complex numbers, they are equal. Let's say we have another complex number with the same value of A and same value of B, so we can say that those two complex numbers, they are equal. So for instance, complex number of 1/2 minus 2/3i. So we can say that 1/2, let's say if complex number 1/2 plus 3/2i. So we can say this is the real parts and this is imaginary parts of our complex number. So complex number, remember that complex number must always consist of real parts and imaginary parts. And sometimes real parts we only have number of 0, but it's still we can consider as complex number because we have real parts even though we have the value of 0. So for one complex number, we can perform the operations like what we can perform for real number. We can perform operations of addition. We can perform operation of subtraction. We can perform operations of multiplication. Also, we can perform operations of division. However, to perform the operations of divisions, we have to know what we call conjugate of complex number first, because we need to multiply by the conjugate of our denominator of complex. We have to multiply by conjugate before we divide two complex number. All right. So addition of complex number, we just add complex number. For example, one complex number, A plus BI, we add with another complex number, C plus BI, A plus B plus C plus D, I. Remember that real parts, we adding with real parts. Imaginary parts, we adding with imaginary parts. Subtractions of complex number, let's say A plus BI, we want to subtract with C plus DI, so we subtract A minus C plus B minus D, I. Also for multiplication of two complex number, we multiply. Let's say complex number A plus BI, C plus DI. We must just multiply A and C, A and DI, B and BI and C, which is BCI, and BI and DI, which is BDI square, and the value of I square for complex number, remember that the value of I square is minus 1. So AC plus ADI plus BCI minus BD multiplied by minus 1, since I square is equal to minus 1. So we can say that AC plus ADI plus BCI plus BD. Minus BD times minus 1 is plus BD. So we can rewrite this as AC plus BD plus AD plus BCI. So we write in standard form, which consists of real parts. This is real parts, and this is imaginary parts. This is real parts, and this is imaginary parts of our complex number. Right. The process or the operations of addition, subtraction, multiplications, divisions also. But for the case of divisions of polynomial, we have to perform, we have to find the conjugate of that complex number. So we need to know what is the conjugate of that complex number. Let's say complex number Z equal to BI, then conjugate of Z given by Z bar. Z bar here meaning that the conjugate of Z, A minus BI. Instead of A plus BI, so A minus BI. So we need conjugate in order to perform the operations of addition, operations of divisions of complex number. Divisions of complex number. For instance, let's say we need to perform, we need to divide, divide complex number 7 plus 3i and divide 7 plus 3i and 4i. So 7 plus 3i divide by 4i. Seven plus 3i divide by 4i. So remember that what we want to divide here is just 4i. 4i here we consider as complex number because 4i is come from 0 plus 4i. We still have real parts and also imaginary parts. A real part is 0, imaginary part is 4i. Real and imaginary. Right. So we have to multiply by the conjugate of for I. So to divide, to perform operations of divisions, we need to multiply by the conjugate of our denominator. So what is the conjugate of for I? What is the conjugate of for I?
Negative for I.
Minus for I. So also numerator, we have multiplied by minus for I. So if you multiply 1 by 1, we're going to have what? Minus 28i, right? You multiply 1 by 1. You multiply 1 by 1. Then minus 28i. Then what? Minus 28i and we concentrate on denominator first. On numerator first. Minus 28i.
Negative 12i power of 2.
A square.
Divide by
Negative 16
Power
I square.
I square.
Change I power of 2 to kepada negative 1.
So we have 12, right? Minus 28i over 16. Right. After we change I square into minus 1, so we will have 12 minus 28i over 16. Over 16. So because we want to write in the form of general form of complex number, so what we do is 12 over 16 minus 28 over 16 I. We separate real and real, imaginary and imaginary. So we simplify.
3 over 4 minus 7i over 4.
7 over 4 I. Right. Any questions?
Sir, can I ask?
Uh-huh.
Why we have to conjugate the 4i?
Because we don't want our denominator now consists of complex number, consists of I. So in order to remove I here, we have to multiply by the conjugate.
Okay, sir.
So when we remove the conjugate, you can see that no more complex number. Okay. So remember that I square is equal to -1. So I only is square root of -1. Right. So if we have a square root, for example, negative number, in fact, we cannot have square root of negative number. For example, square root of -16. What we do right is square root of 16 multiplied by square root of -1. Because remember the laws of radicals, -16 can be written as square root of -16 can be written as square root of 16 multiplied by square root of -1. We multiply 16 and -1 there. So it's like the square root of 16 I. Square root of -1 is I. Similarly, the square root of -3, for example, we can rewrite as square root of 3 multiplied by square root of -1, which is square root of 3i. Which is square root of 3i. Let's say we want to evaluate or we can say the find a value of square root of 12 minus square root of -3 multiplied by 3 plus square root of -4. Square root of 12 minus square root of 3, square root of -3 times 3 plus square root of -4. Square root of -4. So we change square root of 12 because we do have here we're going to have square root of 3. So we change square root of 12 to be square root of 4 times 3, because later we're going to have square root of 3 as well, because here we change it to square root of 3 times square root of -1, because we're going to have square root of 3 there, multiplied by 3 plus square root of 4 times square root of -1. So here it's square root of 4 times square root of 3 minus square root of 3i, square root of minus 1, we write as I, plus 3, square root of 4 is 2, 2 square root of minus 1, I. So we have square root of 4 times square root of 3 minus square root of 3i plus 3 plus 2i. Right.
Sir,
Yes.
if I put 6 times 2,
6 times 2 is okay, but you going to have square root of 6 times square root of 2. You're going to have, because the reason why I choose 4 times 3, because we're going to have square root of 3 there. So we're going to have square root of 3, same as this. You can choose 6 times 2, but 6 and 2, we don't do anything, right? It's still correct. So when we do like this, it's going to be 2 square root of 3 minus square root of 3i times 2 plus 3 plus 2i. And now we expand. We expand, which means that we multiply 1 by 1. So expansions 3 square root of 2 square root of 3 times 3, 6 square root of 3 minus or plus, right? 2 square root of 3 times 2i. So we have 2 times 2 square root of 3i. And then 2 square root of 3 multiplied by 2i. 2 square root of 3 multiplied by 2i. We multiply. But we write 2 in front first. Does not matter. Because 1 multiplied by 2, 3 multiplied by 4, same as 4 multiplied by 3 multiplied by 1. So it does not matter which one we do right first. When they multiply. Minus square root of 3, right? Minus, because minus here, square root of 3i multiplied by 3. So we have 3 square root of 3 I. Then the last one is square root of 3i multiplied by 2i. So we have 2 square root of 3i square. 2 square root of 3i square. As you can see now the reasons why I changed to square root of 12 to square root of 4 times 3. Because we want square root of 3, and later we're going to see square root of 3 and square root of 3. So we only have square root of 3. So 6 square root of 3 plus 4. 2 times 2, that's 4 square root of 3i. Minus 3 square root of 3i. Minus 2 square root of 3 minus 1. I square is minus 1. I square is minus 1. we have 6 square root of 3 minus or plus, right? Minus and minus plus. Plus 2 square root of 3, then plus 4 square root of 3i minus 3 square root of 3i. Remember that minus and minus plus, so it's plus 2 square root of 3. So 6 square root of 3 plus 2 square root of 3 is 8 square root of 3 plus 4 square root of 3i minus 3 square root of 3i. So 4 minus 3, 1. So just square root of 3i. So 8 square root of 3 plus square root of 3i. So how do we evaluate that? By making minus square root of minus 3 and square root of minus 4 as square root of 3 multiplied by minus square root of minus 1, as square root of 4 multiplied by minus square root of minus 1, where square root of minus 1 is I. Since I square is minus 1. So square root of minus 1 is I. Right.
Sir, I have a
Yes.
question. The first one,
Mm-hmm.
my square root 3 and my square root negative 1 will become square root 3i, right?
Square root
Bawah.
of minus,
Square root 3 dengan square root negative 1 will be square root 3i, kan? Tapi yang the square root 4 and square root negative 1 jadi 2i je.
because we change. We change square root of 4 into 2.
Oh.
Yeah, we do not change. We remain as square root.
Oh, thank you, sir.
And let's say we want when let's say given to us x plus yi divide by 2 minus I equal to 1 plus for I. Find x and y. Now, we want to find what's supposed to be the value of x and what's supposed to be the value of y there. So because this is the metric complex number, we divide divisions of complex number. So what we have to do is we have to multiply by the conjugate of denominator of our complex number. So x plus yi, 2 minus I, we multiply by the conjugate of denominator. What is the conjugate of denominator?
2 plus I.
2 plus I. So we multiply with 2 plus I and 2 plus I there. 2 of 2 plus I. So what we do is we multiply both numerator, denominator, we multiply. So what do we have? After multiplications,
Two x
plus xi
plus 2yi
2yi
plus yi power of 2.
Okay.
2 power of 2
Okay.
tolak I power of 2.
Okay.
And change the I negative 2
To negative 2. Right. To
by
negative 1,
negative
right?
1 and atas tu juga.
Right.
So
Then
2x plus xi
x plus xi
plus 2yi minus y
minus y
and 5.
divided by 5.
That's all.
It must be equal to 1. Equal to 1 plus 4i. Because it's equal to 1 plus 4i. Then we put together terms of real and real, imaginary and imaginary. So real and real only, to x and y, they are real. So 2x minus y plus imaginary and imaginary, x plus 2y, xi plus 2yi. They are imaginary, therefore we're adding x plus 2yi. We separate real and imaginary. Divide by 5 equal to 1 plus 4i. And if we want to separate more, we can rewrite as 2x minus y over 5 plus x plus 2y over 5i equal to 1 plus 4i equal to 1 plus 4i. Then
Compare kasi.
compare to x minus y, x plus 2y, 4. So you're going to get two equations here. 2x minus y over 5 is 1. And x plus 2y over 5 is 4. Are two equations. Name this equation 1, equation 2. So we can solve, we can find the values for x and y by using simultaneous equations. And I'm sure that simultaneous equation not new for you. You encounter many times before of simultaneous equations. So you solve using simultaneous equations. Where you're supposed to get what's the value of y you have and what the value of x you have.
X equal to 6, sir.
No. You must supposed to have y equal to 7.
Yes, X equal to 6.
X equal to 6. You're supposed to get those two using simultaneous equation. I think no problems are using simultaneous equation. Since we only have, we make this equation as 2x minus y equal to 5. Here x plus 2y equal to 20. And then solve because this is only linear. Using simultaneous equation, you're supposed to get y equal to 7 and x equal to 6. So I hope that no problems of simultaneous equations. Since I think you encounter with the simultaneous equation many times before, right? And we talk about simultaneous equation, only simultaneous equation for the linear. So no questions. Right. Take a break and we come back at 11 o'clock. Right. Take a break for a while. Right. Come back at 11 o'clock. Right. Welcome back. Let's say questions is find values of x and y if x minus 2i over 2 plus I plus 2 minus yi over 1 minus I equal to 1 minus 2i. We need to find what's supposed to be the value of x and the value of y. First, multiply by conjugate. Because we don't want our denominator consists of I, so we need to multiply by the conjugate. So x minus 2i over 2 plus I multiply by 2 minus I over 2 minus I, conjugate of our denominator, plus 2 minus yi over 1 minus I. Also, we need to multiply by the conjugate. 1 plus I over 1 plus I equal to 1 minus 2I. Equal to 1 minus 2I. So now we need to multiply by the conjugate. So what we have to do is 2x multiply 1 by 1 minus xi minus 4i plus 2i square divide by what?
2 square minus I square.
So at the end you're supposed to get
5.
5
Yes.
plus 2y as 2 plus 2i minus yi minus yi square divide by what?
2.
2 divided by 2 equal to 1 minus 2i. Equal to 1 minus 2i. And now expansions to x minus xi minus 4i minus 2 over 5 plus 2 plus 2i minus yi plus y over 2 equal to 1 minus 2i. Right. Then 2x minus 2, that's imaginary parts, plus minus x minus 4i divide by 5. Right. Plus 2 plus y plus 2 minus y I divided by 2, 1 minus 2i. Nah. Right. So we have two fractions here, and they do not share the same denominator. We want to make same denominator. Ten. So 2x minus 2 plus minus x minus 4i must be multiplied by 2, since 5 here multiplied by 2 in order to get 10. So numerator become 4x minus 4 plus minus 2x minus 8i. After we multiply by 2, minus 2x minus I plus 5. 2 here must be multiplied by 5. So 5 plus 5y minus 10 plus 10 minus 5y I equal to 1 minus 2i. Here is 2 multiplied by 5. 2 multiplied by 5 is going to be 10, right? 10, sorry, 10. 10 plus 5, y must be multiplied by 5. 2 multiplied by 5, y multiplied by 5. So what do we have is okay, for x plus 5y. Now we talk about real parts. We don't go for imaginary parts yet. For x plus 5y minus 4 minus 10 minus 4 plus 10, we get
6.
plus 6. For x plus 5y plus 6. This is even real parts. Plus imaginary parts minus 2x minus 5y minus 8 plus 10, which is plus 2. I over 10 equal to 1 minus 2i. You get that? How do we obtain for x minus or plus 5y? We talk about real parts, no imaginary parts yet. For x plus 5y, then minus 4 plus 10 plus 6. And then we go to imaginary parts. Minus 2x minus 5y minus A plus 10 plus 2i equal to 1 minus 2i. So we have, before we have for x plus 5y plus 6, this is the last one, plus minus 2x minus 5y plus 2i over 10 equal to 1 minus 2i. When we bring this 10 into right hand side, so what we do have is 10 minus 20i. And we no longer have fractions in our right and in our left. So it's become like this. For x plus 5y plus 6 plus minus 2x minus 5y plus 2i equal to 10 minus 20i. So if we compare so what do we have? We can say that for x plus 5y plus 6 equal to 10. And we can say that minus 2x minus 5y plus 2 equal to minus 20. Again, we can solve using simultaneous equations. Using simultaneous equations. So we can make this as for x plus 5y equal to 4 minus 2x minus 5y equal to minus 22, where we bring to the right. So we have two equations here. We can name this as equation number 1 and equation number 2. A simultaneous equation again. when equation 1 plus with equation 2, you get minus 6x equal to minus 18, x equal to 3. Oh, sorry, reason not minus 6x. 1 plus 2. 2x here. 2x. So x equal to minus 9. X equal to minus 9. Once you get x equal to minus 9, definitely you will get the value of y. Y equal to 8. Y equal to 8. We get the value of x and y there. Once we reach up until a simultaneous equation, and once we get the value of x, definitely you will get the value of y. Once we get the value of x, we will get the value of y. And let's say given z1 equal to 2i, z2 minus 4i plus 3, then express 1 over z1 plus 1 over z1 minus 2z2 in the form a plus bi. Given two complex number, 2i and minus 4i plus 3. So express or write 1 over z1 plus 1 over z1 minus 2z2 in the form of a plus bi. So 1 over z1, 1 over 2i. z1 is 2i. Plus
1 over 6i.
1 over
6i.
2i minus 2 z2 minus 4i plus 3. We still have plus 3 there. So 1 over 2i plus 1 over 2i plus 8i. Or not plus 8i here, right? 2 times 1 over 2i here is going to be what?
plus
plus
8i
8i
minus 6.
minus 6. So 1 over 2i plus 1 over
10i.
10i minus 6 plus 10i. Right.
Conjugate.
So two fractions here. So conjugate of both before we add.
Conjugate lah.
1 over 2i multiplied by minus 2i minus 2i plus 1 over minus 6 plus 10i multiplied by minus 6 minus 10i minus 6 minus 10i. The conjugate of minus 6 plus 10i is minus 6 minus 10i. So here we get minus 2i divided by what?
4.
4 plus, here we get minus 6 minus 10i divided by
Negative 46.
multiply 1 by 1. Minus 6 and minus 6.
36 minus
36
plus
plus
plus 100
so 136
negative 1.
right?
Negative 1 say.
Huh?
I square right?
I square.
Ah.
So minus 1 minus 136.
Yeah.
No, 136. Betul lah tu.
136 je.
36 and minus.
No negative.
No, no minus.
Negative.
No
I
minus.
square
Sebab dia negative
Sebab
100.
Sebab dia negative 100.
So negative 100 and negative 1. So plus. Like that.
Yes, sir.
And now, denominator different. We want to make denominator same. So what we have to do?
Times 34.
Times?
34. 4 times 34.
4 times 34.
Yes.
So here must be times with 34 as well.
Yes.
So minus what?
68.
Huh? 68. Minus 68i over 136. What's that?
Yes.
Plus with minus 6 minus 10i over 136. So minus, so we have denominator 136 now. Minus 68i minus 6 minus 10i. Looks like that. So minus 6 over 136 minus 78 over 136i. Minus 98 minus 10 minus 78. We can simplify to be minus 3 over 68 minus with 39 over 68i. Right. Find the square root of 6 plus 8i equal to a plus bi. This is the square root of that. So we need to find the square root of 6 plus 8i. So the square root of 6 plus 8i. So imagine this is a plus bi. And in other words, we need to find what is a and what is b. And the square root for 6 plus 8i. So always, in order to remove square root, what we have to do? What we have to do in order to remove the square root in our left? What we have to do in order to remove the square root in our left?
Power 2.
Power of 2. Therefore, 6 plus 8i square root, we square. So, when we square in left, is equal to square on right, we square on our right as well. Square on our left and square on our right. Six plus 8i equal to what? Equal to
S squared plus
a
bi squared.
plus,
Bi squared.
not just plus bi square. Plus what?
2
Negative b.
I
2 ABI.
2abi
Plus
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 bi
bi squared.
I square. Six plus 8i a square to abi plus b square I square. 6 plus 8i equal to a square 2abi plus b square minus 1. Six plus 8i plus equal to a square minus b square plus 2abi. Comparison. A square minus b square equal to 6. 2ab equal to 8. A square minus b square equal to 6. 2ab equal to 8. We can find using simultaneous equation again the value of a and the value of b. So using simultaneous equations, you're supposed to get a has two values. Plus minus 2 square of 2. B has value of B has two values as well. Depends on the values of A. Plus minus 2 over square root of 2. The value of B depends on the value of A. Whatever the value of A we choose, that's the value of B. We choose the value of A, that's the value of B. You try to obtain the value of A and B here. Right, I stopped the sessions today here, and inshallah we'll see you back on tomorrow at 11 o'clock. I see you again, and I close these sessions. We start speaking for Surah Al-As. Subhanallah. Bismillahirrahmanirrahim.
Thank you, sir.
Welcome.
Thank you, sir.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you, 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 sir.